right? We're asked for the pH of a buffer, and we make this buffer by mixing 30 milliliters of 1.2 molar HF, and we're going to mix that with 20 milliliters of 2.3 molar potassium fluoride. They tell us that the Ka, right, for HF is 7.2 times 10 to the minus 4. So this is kind of 2-in-1. It's not just a straightforward Henderson-Hasselbeck equation. We are mixing these two together. So we actually have to find our new concentrations at our new volume. So for both of these, we have to do an M1V1 equals M2V2. So we'll start with the HF, right? M1V1 equals M2V2. Our initial molarity times my initial volume equals my new molarity at my new volume. So initially, I have 1.2 molar HF and I have 30 milliliters of that. I want to find my new concentration at my new volume, which is 50 milliliters. Do the same calculation with the potassium fluoride, the conjugate base. Initial concentration is 2.3 molar. Initial volume is 20 milliliters. What's my new concentration at my new volume of 50 milliliters? So multiply and divide by 50. So 1.2 times 30 divided by 50. And my new concentration here is 0.72 molar HF. And then 2.3 times 20, divide that by 50. My new concentration here is 0.92 molar potassium fluoride. Now we can do the Henderson-Hasselbeck equation, right? pH equals pKa plus the log of my base over the concentration of my acid. So pH is the negative log of 7.2 times 10 to the minus 4 plus the log of my base. Potassium fluoride is my base, right? That's the conjugate base. Potassium is the conjugate base of HF. So 0.92 over 0.72, the concentration of HF, concentration of my acid. So pH equals negative log 7.2 times 10 to the minus 4. Right, that is 3.14. We have a higher concentration of our base, so our pH, our final pH should be higher than our pKa, should be higher than 3.14. So we've got the log of 0.92 divided by 0.72. All right, we're adding in 0.106. My final pH equals 3.25 for this buffer. The trick being, this first step right here, that we can't just plug in those concentrations and do the Henderson-Hasselbeck equation because we're mixing the two solutions together. So we're going to have a new volume. Because we change the volume, we change the concentration as well. So M1V1 equals M2V2 to find our new concentrations of both the acid and the conjugate base.